Ladies and gentlemen, welcome to the webinar. Today we have Mark Stevenson with Neurosports Science. He's going to be presenting content on the rehabilitation process that he's developed. You are welcome to ask questions of Mark directly to the left-hand side in the Q&A box. If you're having any type of technology issues with the application, feel free to ask those questions there as well. In the upper left-hand corner, you'll see a live streaming video feed of Mark. In the center is our actual content portal where our presentation will be held. We look forward to everybody enjoying this session. We have approximately 30 minutes set aside for the session with 15 minutes of additional Q&A. I'd like to welcome Mark Stevenson today to present to our audience. And thank you so much, Mark, on behalf of Sparta, and welcome to the Recovery and Regeneration webinar.
Well, thank you. I appreciate it. Welcome, everybody. Thank you for attending today's discussion. The topic today is going to be recovery and regeneration. And one of the reasons why I chose this topic is because recovery is a very important part of what we do with our athletes. It's more of a hot topic these days, and as well as the importance of it, and really understand why we need to recover and what we're trying to do with that. So I'd like to just quick overview of what we're going to talk about today. Is when we're going to define recovery and regeneration, what are we really talking about, and specific to this discussion here, how the brain-body connection, what the role is with that, and stress, the influencers, and also, how do we approach, recovery in our practice, and as well as obviously the technologies. And technologies are going to be really important topic today. We're not going to get too much of the biology and the physiology, but we definitely are going to talk about some of the effects of technology that we know has been working to date. And then there's some, and we'll, at the end, talk about a little bit about what may be coming in the near future, hopefully. So what I'd like to do is just really define what we mean by recovery. Normally recovery is getting back to the normal state, but in athletics and performance, really talking about recovery as a return to a state of readiness and readiness to perform. And that's a key aspect because, it's not just recovering from, the game or, the day, but it's being able to be recovered and ready to go the next day, whether it's training, tactical practice, or is it a game situation? So those are the important things. And when we talk about regeneration, we're really looking at forming and rebuilding new pathways, whether it's metabolic or neurologic pathways. But those are the things that we're really trying to do in that regeneration process. And we'll talk a little bit more about where we want to get down to. And basically, we're looking at trying to get down to the deepest levels of the cellular level. So I'd like to talk a little bit about the brain-body connection, and those of you that have seen some of presentations I've done in the past on brain-body connection, this will be a brief overview of that. But essentially, what we're looking at is how do we get down to that cellular level? So it's starting at the brain, its connection to the physiology and how it interacts, right down to the mitochondrial level. And that's where the repair, recovery, and the replenishing take place. So let's talk about the brain first. So what I like to do, looking at the recovery process, is really take a brain-first approach, okay? Because the brain is the guidance of the whole thing, right? That runs everything. So, it's a perceive, process, react situation. That's how the brain operates. Okay, so, is it a threat, fight or flight? Do we have to remain hypervigilant? Can we relax? Is it emotional? And then, what do we do? What's our decision making? Are we going to be, into our primal brain where we're just going to react for survival? Or can we do a slower process where we can actually make logical decisions? And that's where the brain-first approach comes in. But I'd like to talk a little bit about, the emotional brain, because that is the tricky part. So when we're talking about stress, performance, we're under stress during performance, under training, things like that, as well as physical stress. But the emotional brain kind of dictates a lot of things. So, as you can see here, there's three aspects that occur. You receive this stimulus, and then, the thalamus receives the message, and then it's kind of like the relay station. Where's this information going to go? The information gets to the amygdala, and that's where we have to decide, are we going to be fight or flight, or are we going to be logical? What do we need to do? And that's kind of the gatekeeper of our emotional processing. Then we can, if the information can get to the prefrontal cortex, then we can start being logical in our executive function, making decisions. The problem is the amygdala tends to hijack the information. So we tend to get stressed when we don't need to be stressed. And when that happens, we start blocking slow thinking activity. All right. So that's, our decision making becomes more emotional versus informational. Okay, so I talked a little bit about that flow of how it goes through, but again, the key aspect is, how do we modulate our emotions? Because the brain is receiving stimulus and then it modulates it, and sometimes that's based off of experience, touching a hot surface, or sometimes it's just, what we say not realistic. And we just make more of it than it is, and that's everybody in all different situations. So how do we modulate that? And when we're in chronic stress, it's harder to modulate that, and that's again where recovery becomes a very important aspect in our training process. The HPA axis, that's kind of where that brain-body connection comes in. That's the interaction right there. That's where it becomes where the psyche and the physiology come together, and we have this brain-body connection. So with the HPA axis, based on the information it receives, it has a negative feedback loop. So, it's going to secrete certain hormones, certain transmitters, and then that will secrete another transmitter and so forth. So when we're looking at the adrenal stress response to this, after the CRH is released and the pituitary gland, receives that information, then says, okay, we got to release some ACTH, and that gets down to, the adrenal gland where it says, okay, well, let's release our cortisol. Could be, do we need more insulin? Do we need less insulin? Do we need, whatever? It could be HGH, testosterone, whatever that is needed, and it's going to secrete that. And then when those levels get to the sufficient level, it shuts it off. So then that information gets shut off, and then we stop secreting. Unfortunately, when we are in chronic stress, that negative feedback loop gets stuck, and it never shuts off. So we just keep flowing and flowing, and then flooding the area. So in stress, it's cortisol. Cortisol starts increasing and flooding the area, and then it starts to shut off other hormones for recovery and healing. So that's where the importance of the HPA axis comes in. So, when we consider stress, it's really perceived pressure, right? So when we're looking at, we have a physical, social, and psychological, and there's all aspects to that. I've named a few here, but as coaches and practitioners, we have to step back and look at all the possible confounding factors that might be affecting our athlete. And that's not always easy to do because we have our own stress and pressures and confounding factors affecting us in our decision making. So, it keeps multiplying in these team situations. It can be difficult, and, it seems like it's really simple, but we're all human beings and we're all susceptible to this. So all our interactions cause other interactions. So it's important that even as a practitioner that we recover and regenerate ourselves so that we can be more effective in helping our athletes. So when it comes to physical stress, and when we have all the practices, it could be muscle injuries, illnesses, allergies, it could be environmental allergies that cause that stress to our immune system. So those are the factors that we have to take in consideration. The social, family, friends, coworkers, bosses, good and bad, things that will affect the athlete. And then the psychological, because we have some biological situations possibly going on, where it could be, extreme anxiety disorders and depression and things of that nature. And, how do we modulate that and how does that fit in? So those are important factors to understand. But when we talk about stress, whether it's chronic, acute, it could be a training stress, or, excitement from, competing in a game, whatever the case may be, we know that it's affecting our autonomic nervous system. So in a nutshell with that, it's really your sympathetic, parasympathetic pathways that are affected. I mean, it's more detailed than that, but essentially that's what's going on. And the key aspect to that is the vagus nerve, and that vagus nerve does a lot for us, and that kind of controls or provides the pathway for information to go back and forth to our reaction to stress, our physiological reaction. So just a little bit on the vagus nerve is it innervates in a lot of different areas. And this is some of the key areas that it innervates, but it's far more reaching than that, because each one of those branches have other branches. In the case of the stomach and the intestines, there's many innervation of the vagus nerve in those areas. So it just keeps bifurcating and branching off. So there's a lot of information coming in that helps the brain decide, okay, what do we need to do to right this situation. So when we're performing, our athletes in general are performing under pressure, and our better athletes can modulate that. Stress is a funny animal. I've seen some elite performers just crumble under a high stress situation, trying to get to the next level. Okay, they're very good, and they're extremely talented at the level they're at. Then they go to the next level, a higher level, where the pressure's a lot more, and they just can't modulate it. And we've seen that, and I'm sure all of you have seen that as well. So when we talk about that, we're talking about the ability to be physiologically resilient, psychologically resilient, and having the right mindset. And to really talk about, that physiological resiliency is that adaptability. So is this athlete adaptable? Can they ramp up when they need to and not ramp up too much? And can they ramp down when they don't need to be ramped up? And that's the adaptability. So that can be situation to situation, in a game like hockey or football, where you're in a play, then you're out of a play. Can you be ramped down in between the plays? Okay. So, that is physiological resiliency. It's controlling your heart rate, respiration, and having a higher heart rate variability when you're not in the pressure situation, and a low variability when you are. So those are aspects of physiological resiliency. Psychological resiliency is similar, but it's the ability to adapt to the psychological situation. Again, we talked about modulating, controlling emotions, not making emotional decisions. I'm sure we've all been in a situation where you've received an email that really ticks you off, and you're responding to it in a frustrated manner. And we know we don't hit send. We'll just save that for later and then go back and retype it the proper way. But emotions can get the better of us, and then it's hard to come back. So the physiological resiliency are those people that can modulate and control their emotions in a high pressure situation. Basically be mindful of what's going on in the moment and what it takes in that moment. And that's, again, a key aspect. And then mindset, having the right mindset, adapt, overcome, reset. Okay, that's, daily, could be within the moment, weekly, whatever. And that is one of the problems that most of the athletes performing have is coming in with the right mindset. They have a lot of talent, a great deal of talent, but when it gets to a high pressure situation, all of a sudden they can't adapt, they can't overcome, and they cannot reset. And, that is, a key aspect. And I purposely put up two gentlemen here that are, one's 40, one's 39, and they're competing at the highest level, and they're competing not only at the highest level, but, still very, very good in their career at this time. And it's mainly because of the mindset that they have going under there, and they have that ability. And of course, it comes from training and so forth, and taking care of themselves. And they both looking at how they recover, and they probably, have different ways to do it, but they know it's important. And that's part of the mindset going in, knowing what's important to keep performing at that level. And that's what makes our elite performers elite. Okay, we have people that can be successful sometimes, and we have people that can be successful often, and that's the difference in performing at a high level and being an elite performer at a high level. So let's talk about some of the influencers of recovery. Okay, we have sleep, which is a major one, and that's a whole other topic in itself, so I'm not going to go deep into sleep as well, but we definitely could be talking a couple hours on that one. Nutrition, again, all these things can stand on their own, but these are important influencers, and exercise is important, as well as the psychosocial, what's going on in their lives. Injury and illness are, always can be a limiting factor and often come up. And the recovery itself, how do we implement that, or do we implement it, or is it just an add-on? And if I don't have time, then I don't do it. Sleep in itself, we know the importance of sleep. We don't truly have a full understanding yet. The advances in brain and neuroscience have told us that we just have so much more to learn, but we do know sleep is important. And we, when it comes to cognitive performance, emotional, tissue repair, we need to be in what we call a very slow brainwave activity, or a delta wave activity. That's the time that the body and the tissue can repair. And again, part of that brain-body connection. Its influences on the immune function and memory. What you've learned gets consolidated and put into long-term memory during sleep, during proper quality sleep. And as well as your ability to control and process your emotions and not let them, again, emotional modulation, if you will. Sleep is a huge influencer of that. And, the biggest part about sleep is it's about the quality of sleep you're getting, not the amount of time. And a lot of these devices, unfortunately, we won't talk about sleep tracking devices today, but rest assured at this point, none of them work to tell us exactly what we need to know. They can tell us how long, they can guess if we're restless or not, but it really doesn't tell us. Without EEG, we can't really tell what's going on. So I think we're getting close. There's some products that are getting really close to getting there where we can do that, but we're just not there yet. Nutrition, another huge factor. We're not going to talk about dietetics, but we're going to talk about basically, the influences that, your insulin response has during the day, especially at night, which can disrupt your sleep. And then that can come in your sleep quality. As well as if you're, starving in the middle of the night, you're not fueling your body properly during the day, and your body needs energy at night and doesn't have it, that's going to disrupt your sleep. But it's more so making sure you don't have an insulin spike in the middle of the night that's just going to wake you up. Okay. Cognitive performance, obviously carbohydrates are important. However, there's, too much can also be a negative effect even in your cognitive performance. Protein, obviously in tissue repair, and again, we need, essential fats to help with that. And then our immune function, all are very important with that. And it does come into emotional regulation, especially when we're looking at that part where, the old Snickers commercials, right? Grab a Snickers bar, because sometimes when we're not having good insulin level regulation, then our emotions get the better of us. So, low carbohydrate really is talking about, minimizing your complex carbohydrates, and choosing the right type of carbohydrates and simple sugars and so forth, and high omega-3 fatty acids are essential when we're talking about stress and recovery. Okay. Exercise, aerobic exercise is important, and anaerobic exercise is important. They're both important. We know people with high aerobic capacity and high anaerobic capacity, ability to buffer, are more adaptable in stressful situations in recovering. So being fit is extremely important. Okay. This really doesn't apply to athletes, but I just want to throw it out there because if you have your corporate people that you deal with, they need to be doing a minimum of 30 minutes 3 times a week to stave off that type of to help with the stress and recovery. But with athletes, again, way more than that. It's just having a balance. If you're in a power sport, don't underestimate the influence that aerobic capacity has. If you're in an aerobic sport or an endurance sport, don't underestimate the influence that anaerobic capacity has. Psychosocial is very important. Family, friends, bosses, media, especially if you're dealing with athletes that are in the college and professional sports, media. Social media is a huge influencer. So hopefully they don't get caught up in that it kind of detracts from what they're doing. And then managing expectations, managing the outside expectations. And people are relying on you all the time, and you feeling your own expectations. Am I letting them down? What do I need to do? Don't put too much on to yourself as an athlete. So it's helping modulate those things. Those are all influencers. And then injury and illness are big influencers. Soreness, joint, muscle problems, surgeries, scar tissue, chronic problems, diseases, illness, allergies are a big one. Certain times of the year, the allergies are going to come in. And what do you need to do? Spend more time in recovery, and what does that mean? Okay, so those things are a big thing. So we talk about recovery analytics, which is again another thing, but we see this a lot now. We're seeing a lot of, okay, what does this all mean? We have all this statistics, all this technology giving us information with the wearables, and how do you put it all together? It's very complex. Okay. But to boil it down, it doesn't matter what wearables we're looking at and what information we're getting, but we're really boiling it down to a couple things. And, we're looking at, the total load, basically, the total load of what's going on is relative to the amount of recovery. So the load might be high, but if you get a lot of recovery, it lessens that load. But that's the key to sustaining peak performance. Okay, so it's really, the load relative to the amount of recovery. Okay, and just a little, when it comes to that recovery, it does come down to quality and type of recovery, and that's where it gets a little bit more. We're going to talk a little bit about that coming up right here. So now with recovery science, we don't have to make it complex, especially when we're talking to our athletes and. What are we looking at? When do we do this? When do we do that? Should I jump in a cold plunge? Should I, just go stretch and foam roll? Those things are, there's a lot of confounding factors with that. But what we can really look at as for the importance of recovery is just treat it like an ATM. All right, your body is like an ATM. All right, you can keep going. So these young guys, 18, 17, 21. We've all done it when we were younger and go out, get drunk and come in and practice, no problem the next day. But we're depleting from our bank account. Okay. If we don't make deposits, we are going to be in trouble. So every time we do those things and we don't recover properly, we don't proper nutrition, proper sleep, or even tissue and cellular recovery, we're making withdrawals. We need to make those deposits. Because if we have a depleted bank account, then we're overdrawn. And that's what happens when we have an overtrained athlete. It's an overdrawn bank account. Okay? So it's really simple. If we don't make those deposits, at some point, we're going to be drained. Okay? So when we look at it from replenishing side of the house, because that's what we're doing. We need to replenish things. We need to repair the muscle tissues. We need to get normal hormone function, back to the, allostasis, state of readiness. That's what we need. We need to replenish, but we need to do that at the cellular level. So, what we know now, and not just in neuroscience, but the anti-aging sciences, as well as the regeneration, tissue regeneration sciences, the holy grail is the mitochondria. So if we can get down and replenish ATP at the mitochondria level, we're getting this cascading effect in the cells and in the tissue, and obviously that's where we're making our money. Okay, that's our recovery. So, we know the mitochondria, that's the powerhouse. That's, where our cellular respiration, ATP, that's where all the energy is coming from. When we have oxidative stress, we have damaged mitochondria that can't repair. So we're depleting our mitochondria. Aging does that naturally. So we're looking at how can we do that. Now, there's new scientists coming out, and we're looking at things like stem cell injections and so forth. Those things are aiming at that. There's some great small rodent animal studies with a couple other type of molecules to help do that. Hopefully we can get them to the human side of the house soon, and take advantage of it. But right now, we have to rely on doing it from the outside. Again, we just talked a little bit about ATP, but that's where we need to work on. We need to be able to buffer. We need to be able to maintain it, and so forth. And then when the mitochondria gets damaged from oxidative stress, we need to be able to fix that. So when it comes to HPA axis, we talked earlier about how it gets stuck in that negative feedback loop, and then it doesn't work, so it just keeps flooding. So what we're trying to do with recovery is resynchronize that. So those are one of our goals. Okay, and again, just going through, from emotional side of the house, decision making, to the hormone level, and to our sympathetic and parasympathetic systems. It's really looking at that. But to do that, we need to assess things, and we can go through many assessments, and we can spend an hour, 2 hours assessing our athletes, but that's not practical, especially in the field. So our assessments need to be, very, they need to be quick, accurate, and actionable. And that's the key thing. So, the work that I've been involved in the past 8 years, we've kind of come up with a way to do that. And again, every day, every week, and every year, it's getting better and better. And, they're still continuing to do work in that area, and I'm excited to see how that pans out. But, I'll kind of tell you where we're at. But looking at, different production from physical performance, we can use force plates. There's different types out there, different softwares that you can use. Again, we want to, accurate, and actionable. Those are the key things. We have a psychophysiological assessment we can do, looking at both the autonomic nervous system and the central nervous system, as well as, functional ability assessments we can do. And then also looking at muscle tone. So I'm going to quickly go over those. So physical performance, this is a force plate technology, but it's actionable. It's accurate, quick, and actionable. And those are the key aspects, okay? So we really want to look at those things that I can turn around and tell my athlete, okay, this is what we can do right now. Because if they have to wait for some interpretation and wait a day or hours, we tend to lose them, okay? Now, if we're discovering something that needs being a little bit more elaborate, then yeah, we can break out some other technologies that can be a little bit deeper, but take longer, okay? So again, actual data is the key to this. The psychophysiological, so, looking at the autonomic nervous system, basically we look at heart rate variability, heart rate, respiration, as well as looking at, the frequencies of the sympathetic and parasympathetic system, which we'll call a balance, the ratios of balance. Right now, just understand with heart rate variability, the only true way to get it is you need an ECG reading. It's not the same as a beat to beat. That doesn't mean you can't use beat to beat, but if you're using a heart rate variability, you might have to take an interpretation which might be beat to beat. But essentially, the products out there mostly are beat-to-beat. There are some that use ECG for their reading. Central nervous system, again, we're looking at DC potential, which is really looking at the resistance that the signal's getting going from, the peripheral to the brain. So, and that is, we can measure that with using a frontal lobe sensor. Functional ability, again, we're looking at a quick, accurate, and actual analysis, and that could be done with technology. It can be done with, observation and so forth. But basically, we're looking for any asymmetrical functions or some dysfunctions and restricted joint movements with that. And again, motion analysis today is getting better and better, and the software and technology is getting better. So there are a few products out there that you can do quick, accurate, and actionable assessments. Muscle tension and reactivity is another one, and I'm actually on purpose using the word pliability, and mainly because a lot is coming up about that, with Tom Brady's Tom versus Time Facebook series coming out. I know athletes have been coming up with questions about pliability because they've heard that a lot in the media. So I'm bringing it up because we're really talking about muscle tension and muscle reactivity. And this might be a way for you to bring some, if you just push it off and say, well, it's not really, there's no pliability, there's none of that, which has been talked about in several professional conferences that I've attended. But the reality is that the athletes are looking to that, and we can make sense of it. Let's not just say, well, that doesn't mean anything. But really what we're talking about is, the resting tension, how tense are you, and the reactivity to that. And we can measure that by sending a signal down there and seeing, how long it takes the muscle to respond to the signal, how long can it hold a contraction, and how long does it stay contracted after the signal is released. So we can do that through light, sound, and electricity. So those are some of the things that work really well. So what we're going to talk about now, which is the technologies, so I'm only going to really discuss some of the technologies that we've found effective. Over the past 8 years, we've been evaluating different technologies for recovery, and we found some that have been highly effective. And there's been some, research, true, empirical research on a lot of these things, and some are still new and don't have enough, and I'll elaborate on it when we get to it. But again, going back to the ATM analogy, we're looking at things and methods that give us a high yield bond, right? So we want a high interest rate. If we're going to invest time into this, we want a high return. All right. So first thing we're going to talk, we're going to talk about like flotation, whole body cryostimulation, cold water immersion, PhotoBioMoulation, compression, and transcranial magnetic stimulation. Those are the technologies we're going to cover today. When we talk about flow tanks, we're really talking about restricted environmental stimulation technique called REST. This has been very effective in the sense that there's a lot of research on it. It's out there. So that's the good part. We've decreased the amount of sensory by putting in an isolation tank. You're floating in 11 inches of water. The density is greater than the Dead Sea, so you're literally neutrally buoyant. So we eliminate gravity, eliminate all this sensory input that the brain is processing. Just sitting down or even laying on a bed, you have pressure. Your brain is calculating all that stuff. When you're in the tank floating, there's far less for it to calculate. The body temperature, the skin temperature, the water temperature, and the air temperature are equal. And you really don't even know where the water begins and the water ends and the air begins. So it eliminates a lot of that. It allows for slow brainwave activity to take place. The research right now is still ongoing on EEGs, but we've done some preliminary stuff. There's a great institute out in Tulsa the Laureate Brain Research Institute, where they do a lot. They have a float study lab there. Dr. Justin Feinstein's doing an incredible job, but what we've seen is definitely getting down to theta level activity, which is like meditation, and then actually some delta brainwave activity for some people, which is deep sleep. So decreased brainwave activity, and we increase heart rate variability. But the thing with this is if you go in, highly parasympathetic or highly sympathetic, it doesn't. When you get out, you don't go to the opposite. What it actually does, it puts you in balance. All right, so that gives us, when we say balance, that's the adaptability. So that means you can be sympathetic when you need to and balance when you don't. And that means you can go parasympathetic when you need to and then balance when you don't. So that's the neat thing about float, that we've found that it's actually very good in all situations, all stress situations. The biggest thing is, like I said, balance on our nervous system when you get out, and the effects last for a while. So there's still ongoing studies on performance and biomarkers, but there's plenty out there that you can draw from in empirical research. Whole body cryostimulation. So basically you have a chamber, then the air is cooled either by electricity or by liquid nitrogen. The most common is liquid nitrogen, because we can cool the air quicker and colder. But at the end of the day, a negative 220 degrees Fahrenheit, whether it's liquid nitrogen or air, it's still negative 220 degrees Fahrenheit. So, with the liquid nitrogen, again, it hits what we call an evaporator, and it actually cools the air. So you have to be careful on the technology, because some of these chambers, especially the less expensive ones, don't do that, and actually you get a liquid nitrogen mist, and which can be dangerous if something goes wrong. Some of the other ones, the more advanced ones, they have an actual evaporator, so the liquid nitrogen never even can get close to the body. So what's coming out is cold air, not liquid nitrogen in that chamber. Even though you still see the steam and everything, one, you get that from the hitting the different temperature in the ambient air that's outside, and two, there's still a mist from that. But it is not actually liquid nitrogen coming out. So it's 2-3 minute exposure, and what we're looking at is what we believe is happening is that you're getting a primal response. So when the cold air is sensed, your brain is like, hey, we're going to die, so we need to send blood to the core, and we're going to increase the temperature of the core. Okay, but we're only exposed for 2 or 3 minutes, so all that blood is pulled away, and as soon as it all gets there, you're done, and then immediately it goes back out. So we have a flushing of the system, if you will, but also, hey, if that happens, damage must have been done, so we're going to start secreting some hormones. So it'll secrete some of, hormones to help with recovery, HGH, testosterone, and so forth. So there is almost a resetting of that endocrine response, but, and a decrease of chronic inflammation. So what we do know is that you actually have a parasympathetic response when you get out. So your vagus nerve, it has a parasympathetic activation for that. So now we can relax because the threat is over. So it's reversing what it wants to do. So it gets us into an adaptability standpoint. Just important to note that it increases the core body temperature, really maintains it and increases it slightly. So if this is a heat illness situation, this would not be something you would do. You would actually make it worse, and the person probably would die. Okay, because you're not cooling the body, you're actually heating the body. So again, we're not sure if it resets that HPA axis, but we think it does, and more empirical studies are needed, and hopefully we'll have some answers in the near future. Cold water immersion, that's been around forever, as we know. Typically, we do know that it will. You first get in there, obviously everything's going to go to the core, but quickly the core gets cooled, and this is obviously why we use it for heat analysis situations. But it gives us an initial sympathetic activation. but at the end, when you get out, you do get a parasympathetic activation as well. So we have decrease in inflammation, both in acute and can be chronic, but it's mostly used in acute inflammation. And again, we have a lower the core temperature because you're in there for more like 10 or 20 minutes, so it's a higher exposure rate. And the contrast baths will help flush some of that system out, and that's used mostly in injury situation. But when we have recovery after, so an example here would be, you just did a heavy 95, 100%, 110% squat routine. Probably jump into the cold tub before anything else, because that would probably be your best recovery modality for that situation. PhotoBioMoulation, it's known as low-level light therapy, but in the literature now, the empirical literature now, it's called PhotoBioMoulation, using a certain spectrum of red and near-infrared light to affect the mitochondria in the cell, and that's where it responds to. It's photosynthesis that we get in the sunlight, but now this is targeting. So it targets mitochondria. Only these spectrums target the mitochondria respond to. Other spectrums, the mitochondria doesn't respond. Now, other cellular structures do, so all different spectrums are good. But what you need to know about this one is it's not the same as an infrared sauna. It's a different spectrum, a different power radiance. For PhotoBioMoulation, you're really looking at like a 17 milliwatts per square meter type of irradiation, that power. And the studies it's MIT, Harvard, and Mass General Hospital's medicine department. They've done a lot of these studies that show the effectiveness. I know they're doing a study right now in conjunction with the University of Texas. I'm not sure which one. I think it's Austin, on concussions, where they actually have a helmet with the LEDs in there at the 17 milliwatts per square meter radiance for the power that penetrates through the skull, and it gets right down to the cellular level. And they're having a lot of success with that. I'm really excited to see when that study is finished and published, but the preliminary stuff is looking really, really good. But again, it increases mitochondrial regeneration. As we talked about earlier, that's what we need to do. So that will help reverse the antioxidant damage or the oxidative damage that you're getting at the mitochondrial level. There's decreased pain, a lot of decrease in chronic inflammation and symptoms. How the ANS is responding, still unclear. A lot of more studies in regards to whole body needs to be done, but in spot sections, the literature is very strong in the effectiveness of PhotoBioMoulation. Compression. We know a gradient pulse pushing from the extremities to the core, to the heart, increase circulation, decrease inflammation, and so forth. This has been used a lot, but we tend to only use it in injuries, but using it in recovery, we find a lot of real good effects from that. So it's a very good tool that it has shown effectiveness. And then we have neuromuscular stimulation as well, where you can stimulate the muscle in the periphery or even the nerve and get some increased circulation, which is the goal of this, to help with recovery and repair. So there's some simple ways to do that that seem to be effective. And then we're coming to that neuromodulation, which is the transcranial magnetic stimulation. Really, the goal of that is to get the brain to operate at 10 hertz. But what we found in neuroscience now, the new studies, that the brains don't always, not everybody's brain operates at the same hertz. So there's there's essentially one method that looks at, hey, if we kind of map the brain first, QEEG, see where you're at, tweak it now and again, get it to see where you're optimal in your hertz, it was more effective than just doing a straight 10 hertz. So with that, two methods came out of that called MERT and or PRTMS, personalized RTMS, which are very, very similar. The MERT is a little bit more complex. They add a couple other things in, not just using QEEG. They use some other measures as well, looking at, the cardiac system and so forth. The personalized TMS is kind of more of a simpler form where they just continue, as the same as Merck, continue to look at your QEEG to make the adjustments. But both have been more effective than just the TMS alone. So, but it's a lot of good literature in the depression, autism, addiction, PTSD, but we don't know about performance. So there are some clinical trials just starting, so it's going to be a while, looking at how it affects performance and recovery. So that will be an interesting one to see come out, and then a couple of new ones will be like, the stem cell studies, and also even a technology that's taking some, simple things like sodium bicarbonate and being able to get it through the body without ingesting it, which obviously it's harder to do. We know sodium bicarbonate works for recovery, but when we ingest it, we get a lot of these negative effects with, IB issues and so forth, and it doesn't all get there. But if we can get it transdermal, we have a better chance. But there's a new technology coming out that actually bypasses the adipose so it doesn't get dispersed. So they started with sodium bicarbonate. It seems to be working very well. It'll be interesting to see how they can expand upon that with medications and so forth. So that'll be interesting that we might be able to get quicker recovery transdermal as well with some of that stuff. So the key aspects here are replenish, repair, regenerate, and recover. So remember, we want to replenish everything, get everything going, from the brain body perspective, mentally and physically. We want to start saving for the future, right? Make our deposits early. We need to repair. That's, reset all the dysfunctions and get everything back to normal and ready to perform, that state of readiness for performance. And then we need to recover. Okay. So, that load, coming in saying, hey, the GPS, the load says that they had a high load day. We don't know, because that's a mechanical measurement. We need to assess the whole body, the whole organism, to say, okay, how much did the recovery affect it, and did that drop our load? And then that's really how we can sustain performance. So we don't want to be fooled by just some of these measurements. We need to look at the body as an organism, not in a two-dimensional manner. So just, again, to sum it up, load is everything that the athlete's encountering, and it's all relative to the amount of recovery taking place. Recovery is the key to sustained peak performance, and it needs to be programmed into your training. That is the biggest flaw that we have. Everybody treats it as an add-on, and things don't take place. So with that, I want to thank you for joining me, and hopefully we can get some questions. I apologize for going over, but it's just a hard topic to fit into 30 minutes or so. So I'll stand by for your questions. I see some questions popping up here. One is, how often can you stimulate the vagus nerve? Well, it's stimulated all the time, throughout moment to moment of the day. But to stimulate it, externally, you can do that. I haven't seen anything that said that you can't do it long term, but usually if you're trying to get someone, it's typically you stimulate to get them parasympathetic. You usually need to do that once or twice, and they can sustain that they can reset pretty quickly. So, Shannon, is there another question out there?
Well, it's stimulated all the time.
Yeah, we have quite a few questions. coming through right now. So I'm just going to push some questions up to you, and feel free to grab the ones that you might want to answer. We've got a few minutes left here to tackle some of these really important ones.
Okay, I will try to, there's a lot, so I'll have to go through just a couple things that might hit a couple. I see some, slides definitely be available PDF. I put my email out there, and obviously any other questions, because I won't get through all these, but you can certainly email me and I'll try to answer. And yes, I will provide these slides for you, or anything, and feel free to email me with other things. But let me just go to let's see. Here's one. Independent of wearables and expensive technologies, are there easy or budget-friendly ways to calculate load effectively and efficiently? There is. Heart rate correlates with a lot of things. Okay, so the down and dirty, if you have to get away with it, then you can use heart rate. A simple, pull a heart rate monitor or anything like that. You don't need any fancy software other than being able to track, heart rate over time. Again, how, if they're stressed, with physical stress or whatever, the heart rate's going to increase and stay steady. And then when they're done, it should, recover, 10, 15 beats within that first minute, and slow down and not be as steady. And that would be a quick, easy way to do that for that one. So hopefully that answers that question there. Let's see if I can grab another one. There's one, when vetting technology, what are the top 3 functions or features you look for? I think I mentioned that. So I want it accurate, quick, accurate, and actionable. Can I do something right away? That's kind of what we're looking at on some of the technology. Is it effective? And you know what? Consumer feedback's huge. That could be the best thing. If the athletes don't like it, they're not going to use it, then it's not going to be any good. So consumer feedback is definitely a big factor when we look at these things. If they like it and they feel it's worked, then we start vetting, okay, does it really work? But if they like it, that's the key. If they don't like it, it doesn't matter whether it works or not. So see if I pull up another question. Let's see. There's a lot about receiving the information. Nutrition is one of the best ways to recover. It's a very important aspect of recovery. So the question is, what are some of the tactics used for maintaining good nutrition habits while traveling? I'm sure a lot of you have different ways. I mean, obviously, I'll work with, a performance dietitian to do the bulk of that work, but it's really having access to quality food. Okay. Sometimes it means shopping. Can we go to, when we're traveling, it's hard. So packing, proper snacks, and then it's timing. Okay. Time zones come into play and so forth. So it's really doing your homework ahead of time. Where are we going? How long is it going to take to get there? And when we get there, what do we have available? So doing that homework ahead of time is really the best tactic for maintaining nutrition habits while traveling. From that perspective. Let's see if I can pull up another. There's one. What do you see as common issues teams are having when trying to get compliance and buy-in? Generation gaps. Okay. It depends on the level of the team. Again, is it something that's convenient for them, for the athlete themselves? If it's not convenient, they're not going to use it. So again, consumer feedback's huge. Buy-in is important. If you don't have buy-in, it doesn't matter. But to get buy-in, you have to have some, proof of concept for them. is it actionable? Is it something, information they can get right away, understand, and do something about? If they have to wait, it goes down in value. But the biggest problem we have is trying to take things that aren't, interfacing well with the athlete. So that's another thing is getting technologies that interface well with the athlete so you can get buy-in. When they're young, again, remember they start with a lot of money. They start with a big deposit, and in their bank account. So they don't feel the pain when they're depleting it. All right, they don't feel it's like your kid when you're giving them, an allowance. They don't know that's coming out of the overall bank account that's going to support the whole family. They don't feel it. So the younger they are, the harder the buy-in is because, again, I'm fine, I recover well. Well, they're just depleting. They just haven't gotten to a critical point of being bankrupt yet. So it's education, trying to make them understand, but not overemphasize something that's just going to turn them off. So on the compliance issue, very, very difficult. We all struggle with it all the time. So let me see if I can grab one more question here. In terms of mindset, this question is: what are some of the tips, exercises to help the athlete with mindset management? The key aspect is, what I look at is basically telling the athlete, listen, when we talk about mindfulness or being mindful, it's really about being in the moment. So you need to focus on the process, not the outcome. If you focus on the process, what you need to do to get where your goal is, not worry about whether you win or lose or am I going to be prepared or not? Those are outcomes. It doesn't matter. If you focus on the process, the outcome is going to be there. So you come back to when they look at highly successful athletes and performers, the people that were successful most often were those that focused on the process, not the outcome. So if they missed a putt, they didn't I missed a putt. Nah, that's one stroke. Then no, it went back to what's the process of going through to make my putt. They didn't worry about the outcome or the past outcome. So when it comes to mindset, that is the biggest tip that I could give, and that's kind of what I do when I educate the athletes. But education is the key aspect to that. So with that, again, if there's any other questions, you can email me. I'll respond as quickly as I can. Yes, we'll make the slides available. I believe you'll get another follow-up email as well, that the recorded version of this will be also available. Shannon, is there anything else?
Yeah, no, absolutely, ladies and gentlemen. Thank you so much for coming to the event today. Mark, thank you again for being our guest and presenting this content. We've had over 100 questions come in, over 100 people live today on the session. So now what I'll do is I'll make sure that Mark gets a copy of all of the questions so that he can answer each of those questions individually with those individuals that didn't have their answer given to them today. Some of the questions are definitely extremely important. So Mark, we'll make sure to get those questions in front of you as soon as possible. Mark referenced the fact this is going to be on demand. It absolutely is going to be on demand. A lot of people have asked about sharing it. Please share it with as many people as you possibly can. This content is extremely important. Now, once again, thank you, Mark, and everybody. Have an excellent day, and we look forward to speaking with you all very soon.
All right. Thank you, everybody.